In today's video, we are going to learn how to solve a house robber problem from the Leetcode. This problem is based on array data structure. Let's understand the problem statement. We will be given an array of integers where each integer represents the amount of money at the ith house. A robber can rob these houses to collect money. Only condition is that robber cannot rob two adjacent houses because that will alert the police. So we need to return what is the maximum amount that can be robbed by the robber. I am going to explain three approaches to solve this problem. First, we are going to start with recursion, and then we are going to optimize our recursive solution with memoization, and then we are going to write a dynamic approach solution for this problem. Let's understand the problem with an example. Let's say we will be given an array of integers. This is the first example where given array is 1, 2, 3, 1. So a robber can start robbing from index 0. Let's say he starts at index 0. He cannot rob at index 1 because these two are adjacent. So he has to skip this second house and he should rob this house. The total amount he will get by robbing these two houses is 1 plus 3, that is 4. And if he decides to start with the second house, that is, let's consider the same example again, and if he decides to start with this house, he cannot rob this one because these two are adjacent, and then he will choose this house, and in this combination robber will get total amount of 2 plus 1, that is 3, and we need to return the maximum amount that is possible for the robber to rob. So this is 4, the maximum amount is 4. So the output for this first example is 4. I hope you understood what the problem means. Only condition is that a robber cannot choose two adjacent elements. So with this understanding, let's understand what are the choices that a robber has at a particular index. At every index I, robber has two choices. At every index I, robber has two choices, and the first choice is rob the ith house and continue robbing from I plus 2, because if we choose I plus 1, I and I plus 1 will be adjacent. So if robber choose to rob this ith house, then he has to skip the I plus 1, he has to start robbing from I plus 2. And the second choice is we can skip the ith house and skip the ith house and then continue robbing from I plus 1. If we are skipping ith house, then we can rob I plus 1. So these are the two conditions we need to understand in order to write recursive solution. Let's implement the recursive solution and check whether it passes all the test cases or not. So we are going to write one more function, and we are going to call this function here. Let's say I'm going to write a max rob. Initial index will be 0, and then I'm going to pass nums vector. Here we are going to implement max rob function. It is going to get an index at which robber has to start, and another argument is vector int and nums. We are taking nums as reference, and after this we have to check whether index is valid or not. If index is not valid, that is, if index is greater than or equal to nums.size, then we should return 0. We cannot rob anything. But otherwise, we have to choose maximum between two choices that are available to robber. And the first choice is robbing the ith house and continue robbing from I plus 2. If we rob the ith house, we are going to get nums of index that is the amount of money that is available at index, plus we have to continue robbing from I plus 2, index plus 2, and we have to pass nums as an argument. And the second choice robber has is he can skip the index that he is at now. He can continue robbing from I plus 1. So that will be index plus 1, and we are going to pass nums as an argument for that function. This is all we need to do in order to implement the recursive solution. Let's run this solution and check whether it passes all the test cases or not. It is passing the initial test cases. Let's submit this recursive solution and check whether it passes all the test cases or not. Okay, we are getting a time limit error. This is expected because in our recursive solution we are doing a lot of repeated calls with the same argument for max rob functions. So this is what is causing time limit exceeded error. So what we can do is, instead of calling max rob every time, we can memoize this solution where we store the return values in a hash map, and we are going to use it for early return. Let's declare a map which maps integer to integer. So max rob value. With this max rob value, we are going to store the return values inside this hash map. So in order to do that, what we should do is, instead of directly returning, first we will check if max rob value dot find index. If it is already present in our hash map, then we will directly return that value. Return max rob value of index. Otherwise, we are going to store this value in our hash map. Max rob value of index will be equal to this value, and after that we are going to return max rob value of index. We just memoized our recursive solution. Instead of calling this max rob function for every index repeatedly, we can cache those values in a hash map, and we can use it for early return in the recursive function. Let's run this function and check whether it passes the initial test cases or not. Yes, this memoized solution is passing the initial test cases. Let's submit the solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. Let's discuss one more approach where we use dynamic programming in order to solve this problem. So in dynamic programming, we build the solution from the base case. So let's understand how can we implement a dynamic programming approach in order to solve this problem. I'm going to reset this code, and let's get back to our drawing board. And let's say we have these numbers 1, 2, 3 and 4. And what we are going to do in dynamic programming approach is, I'm going to write the index as well. Here I will be 0, 1, and here I will be 2, and here I will be 3. So in dynamic programming approach, we should be aware of what is the solution for base case. Let's say we have only one house. What is the maximum value that robber can rob? That is 1, because there is only one element which is present. Let's say there are only two houses. What is the maximum value a robber can rob? That is 4. That is maximum between these two values. He cannot rob both because both houses are adjacent to each other. So with this understanding, we can write a dynamic programming. Let's define our dynamic programming array. I'm going to explain this with the code. Let's declare an array maximum rob value till it is an integer array, and after this it has to be of size nums.size. So we have this array max rob value, and what we should do is we should fill up base case first. What is the maximum rob value till index 0? So if a robber is allowed to rob only till index 0, what is the maximum value that a robber can rob? So for that, base case is nums of 0, because if robber is allowed to rob only till index 0, then the maximum amount he can rob is whatever the value that is present at index 0. And another base case is what is the maximum rob value till index 1. So for this case, we have to choose between what is the maximum between first and the second element. If a robber is allowed only to rob till index 1, the maximum amount he can rob is the maximum amount between first and second position. So for this, answer will be max between nums of 0 and nums of 1. So here we are accessing 0 index 0 and index 1. For that we have to do some sanity checking before proceeding here. First we will check if nums dot size is 0, then we will return 0. Otherwise we will check if nums dot size is 1, then we should return nums of 0. Then what else are we accessing? Okay, for the remaining cases it is fine. So I think these two base cases will handle this array index as well. But from 2 onwards we can this solution works. So then we will compute other values using previous values. For index I equals to 2, I less than nums dot size, and I plus plus. So what is the maximum rob value at index I? So here robber has two choices. That is, he has to choose max between nums of I plus max rob value of I minus 2. He cannot choose I minus 1 because I and I minus 1 are adjacent to each other. Otherwise he has to choose maximum between, he has to start he can choose max rob value of I minus 1. He can skip the ith house and he can consider I minus 1 value. And after completion of this for loop, we have to return what is the maximum rob value at the last index, because this represents the amount a robber can rob by considering all the elements. So that last index will be nums dot size minus 1. Let's run this solution and check whether it passes all the test cases or not. We have a typo here. If we change max rob value till so let's run this solution again and check whether it passes the initial test cases. It is passing the initial test cases. Let's submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. I hope you understood recursive approach, and then memoization, and then dynamic approach. Thanks for watching this video.